from whatever part
This
of the world
meeting is being recorded.
you're attending. Uh, Today's session is about stages of projects in oil and gas industry. So I will try to put it in form of a story, just to make it interactive and interesting to everybody who is attending. Some points, some aspects might be familiar for the experienced engineers, but there could be some aspects which are which are new to the people who are either interested to enter into this industry or already entered into the industry, but they do not have much of the experience. So without wasting any time, we'll move to the next slide. This is introduction about me, and my name is Parimal Deshpande. I'm a freelance process design engineer. I have 17 plus years of experience into process engineering, basic and detail engineering for oil and gas facilities and hydrocarbon processing plant. I have majority of my period I have worked in India, and as well as I have worked for a few years in Middle East, including UAE, Oman, and Saudi Arabia. Today's topic is how the projects in oil and gas industry moves across various stages. Expected audience is a fresh graduate interested about this field, working engineers from various disciplines, not only process or chemical or petrochemical. Other discipline engineers are also expected and are welcome to join here. Experience range expected is to the tune of 2 to 3 years, because most of the things which we are going to discuss here or which I'm going to present here might be familiar with people who are having experience more than 5 years. Duration is expected to be 40 to 45 minutes with total 15 to 16 slides. And we'll try to have a 10 or 15 minute session for Q&A. Yeah. So there are few terminologies which we should and everyone should be familiar, like FEED, which is abbreviation of front-end engineering and design. Some companies, some government companies, which are also called national oil companies, NOC across the world, they prefer to call it FEL, like it also has the same meaning like FEED. It's just called front-end loading. Then basic engineering, concept stage. Concept stage is again another name for FEED stage or FEL stage or pre-FEED stage, I would say. So concept stage is a typical word used by National Oil Company of Oman, which is Petroleum Development of Oman. FEL is a typical terminology used by Aramco in Saudi Arabia and other companies by Saudi Arabia. Then there are terms called upstream and downstream, which again significantly used in oil and gas industry. Where roughly we can say upstream is where oil and gas exploration and separation of oil, gas, and water and other ingredients is associated, and downstream is basically termed as refinery, sometimes petrochemical complexes. EPC, LSTK, EPCM, these are various terminologies used by engineering and construction companies in this field. EPC stands for engineering, procurement, and construction. LSTK is lump sum turnkey. Then another term is EPCM, engineering, procurement, and construction management. Another type of contract is cost plus contract, wherein some of the clients, they prefer to go with this cost plus contract with construction companies, is that they agree upon some cost markup like 5 or 7% over and above the cost of the equipment, like handling charges kind of thing. So this is also a type of contract I have come across. Let's start with the story, and this story which I'm going to tell you about is a plant located in Borma district of Algeria. This plant is known as Almark plant. As you can see, this is purely in the middle of desert. Algeria is a country which is located in the middle of desert, and initial days. Let's start with initial days when a government company or a government, they decide to do exploration of site, or they decide to do a development of a particular field, wherein they are pretty much sure that there are some known resources available, or oil and gas storage is available beneath the ground. So initial days, which involves identification of the site, which also involves geological survey, quantity estimation, test well drilling, analysis of samples collected from test well in the lab, and based on that, they try to classify whether it is sour field, H2S is present or not. What could be the contents of reservoir? Is it mainly oil, mainly gas? What kind of content of the gas? So these stages, like which are called initial days, various government agencies work with consultants which are associated with geological surveys and analysis and labs. Then the next step. This is one photo of the Almark plant. I believe this is available on open source internet. This is somewhere between middle of the construction phase of this project. And the next slide, which I'm going to show you, is the runway which was constructed for this particular project. And this was near the town of Hasi Masood, I believe. And you can imagine by looking at the vast desert that how remote this site possibly is. When I was working on this story, I talked to many friends of mine who work particularly to the core of this project. I heard from them. I understand that the only way to reach this site was in initial days was by flight. There was no road connection from nearest town to this particular site, and the only way people could travel was a charter plane. After, I'm sure after when the construction started moving on, they had to move the heavy machinery to the site, so they had to build a road first. So you can imagine a situation wherein a government company or an organization, they want to explore oil, but the basic infrastructure, they had to start from basic infrastructure to reach to the site. Forget about next steps of exploration and all. They need to build roads to reach the site. They need to mark identification marks to reach the site. Again, this is just a location mark on the map. This is, as you're seeing, this is the north tip of North Africa continent and Algeria country. Again, middle of desert. The nearest town, I believe, was having only a population of around 3,000 or 4,000 people. Yes. Then after these initial days is a main concept stage, or as we call it, as a pre-feed stage starts. I am just taking a little break just to make sure everybody is able to hear me. Guys, if you are able to hear me, just let me know. I am getting some messages. Uh, if everybody is able to hear, yeah, okay, you can put a message. Yes, I got a message from Arjun. Yes, I am audible. Great, thank you, guys. So moving ahead, we'll jump to the concept stage or pre-feed stage. Usually, this stage is expected to last 16 to 24 weeks, depending on what facilities we are looking at. So, just for the simplicity, we are looking at. Imagine we are looking at a full-fledged facility which will be separating oil, or sometimes it is called condensate gas, and probably some amount of associated water, or which is also called produced water from these. So this site will involve utilities, this site will involve storage, this site will involve transportation mode like pipelines and other things. So in the concept stage, uh, most of the concept stage, they operating companies, they do at their end, or they try to involve engineering contractor to support them in this. So activities which are followed in these stages are purpose of the facility is identified. Yes, whether they want to produce oil or gas. Now remember, this decision will be taken based on what analysis they have done in initial days. So yes, the purpose of the facility needs to be defined very much clearly. Capacity and major operations expected are defined in the stage. Like for example, desalting of oil or dehydration of gas. These are again decisions taken based on initial analysis of initial days. Again, the capacity of major operations and type of major operations are defined by looking at capital investment or capital cost and life of the facility. So suppose there are expected to be X amount of barrels of oil or Y amount of SCFD of gas. Certain figures are estimated for exploration with an gradual increase as we move ahead in the years. So based on that, it is estimated that the facilities could last or the field could last for like 30 or 40 or 50 years over the period of time. And based on that, future productions or increase in future productions are planned. Scope is defined in this stage mainly with engineering contractor. Engineering contractor is involved in sometimes. Sometimes this concept stage or pre-feed stage, engineering companies, they do some work on their own with their in-house teams. Yes, but if the engineering contractor is involved, there is an active participation from end user slash client side. Client side, when I say client side here, client means national oil companies like again PDO, Oman, or national oil companies in Algeria. Financial estimation at client side is started. Remember this, we are talking about investment of probably billions of dollars, including infrastructure, roads, which are not directly related to that particular facility, but are very much important and crucial. So financial estimation is a very crucial part in this stage. And this is the stage wherein government companies, they decide whether to develop this field on their own by looking at their own bank balances, or they wish to invite operating companies or other interested investors across the world. Most of the developing countries, they prefer to lease out these fields or invite other investors to reduce the financial burden directly on government or government companies. Items other than major scope, as I said, access road, logistic from construction are also considered in this discussion. Uh, Most of these construction companies, they have their own logistic teams who start mobilizing people at this stage and who need to consider possibility and obstructions of reaching this site for major construction equipment. After this pre-feed stage, the project is entered into feed stage. This is mostly 24 to 36 weeks, again depending on size. So pre-feed stages simulation is started, and we can say it is a skeleton of simulation is completed in pre-feed stages. So feed stages simulation of the main process is finalized or at least developed, because sometimes this data which is coming in from the analysis side by different test wells is still in progress, and more wells are drilled to get overall feel of what kind of hydrocarbon content we are dealing with. So simulation probably in feed stage also there might be some changes in simulation in terms of composition, minor changes, yes, in terms of pressure, temperature parameters, yes. Uh, then process is selected. Rarely licensors are required in oil and gas projects. Mostly, in particularly oil and gas project, licensors are required if sulfur recovery or sulfur handling units are associated. If there are some molecular sieve based drying of gases, yes, then there could be some licensor for those products. Remember when I say or when anybody use the word licensor, the heart of the process is the catalyst. So if there is a catalyst involved, then there has to be licensor or somebody who has done extensive research on that process. So most of the oil and gas projects, they do not need a catalyst, so rarely a licensor is involved. Uh, yes, next aspect, biggest aspect is utility and storage, which takes up a major share of investment, hence critical from the overall cost point of view. When we are talking about utilities, it includes steam, if at all it is feasible at some sites. There are some sites in particularly in deserts wherein there is water is there is a very high shortage of water. So steam is, yes, most of the time the steam is avoided. So the heating utility is hot oil. Other utilities like instrument air, plant air, then nitrogen. These utilities, they are estimated, and most of the time they are processes to develop these utilities. These are those are finalized in the stages. Storage, yes. When we say about storage, it is storage of crude oil, storage of incoming crude oil, storage of outgoing crude oil, produced water, which is most of the time again injected in the well to maintain the pressure of the reservoir. Then storage also involves gas product storage. If the agenda of the facility is to generate LPG or propane gas, or which is then injected into the national grids or national networks, then yes, gas storage is also involved. Basis for storage is finalized again in this phase. When I say basis, it means a number of days of storage, types of tanks, depending on what type of crude is handled, the vapor pressure and the properties of these crudes. Then modes of transportations are identified. Facilities which are very big in nature, they don't depend on road transportations for transportation of product most of the time. They depend on pipelines for transportation of their products. So pipeline for oil, pipeline for gases, these are the modes which are identified. And pipeline engineering, which involves basic engineering facility, much less compared to a hardcore facility. So these phases or basic engineering phases for pipeline projects, they move very fast, very quickly. And during feed stage, or probably near the end of the feed stage of the project, pipeline contracts are awarded to construction contractors. The aim is to finish the pipelines near or around when the mechanical completion of the main facility is expected. So pipeline projects which involves probably hundreds or thousands of kilometer piping. Most of the pipings, the highest or the longest piping I have come across was for a finished product petroleum transportation. This was in Saudi Arabia. It was around 400 kilometer pipeline. So these contracts, you can imagine a time required for construction of these pipelines. So hence that's the reason why these contracts are awarded at very early stage. Uh, now we are talking about other documents, or we're talking about main facilities. So PFDs and PNADs are developed for this facility in feed stage. Data sheet of main equipment, static process equipment such as separator, tanks, columns, heat exchangers are also developed. Heat and mass balances are finalized. Data sheet of main rotary process equipment such as pumps, compressors, turbines are developed. Process data for major instrumentation item is developed. At this point of time, other disciplines such as piping, instrumentation, and electrical are also involved. They start moving on based on inputs received from their respective disciplines, like piping, instrumentation, mechanical. They start receiving inputs from process discipline in terms of data sheets, PNID, and they start developing their own basis of designs for mechanical design, for instrumentation design, electrical, civil design. They start working on those things. Other disciplines, as I mentioned above, start their own developing their deliverables, such as basis of design. Basis of design is one of the major document to be developed by each discipline, which describes basis of design to be considered for the respective design. For example, loads and site data to be considered for a structural design for civil. Then electrical power load and other basis items are finalized and freezed and recorded in the basis of design for electrical discipline. Civil, they identified at this stage major structures and their design. Likewise, electrical identifies major drives and motors and design requirements. Most of the time, the power generation for these remote facilities, power generation is also part of the scope as part of the utility. So gas fired turbines are envisaged. They are expected to generate the power required for the operation of this facility. Then instrumentation team, which I can share that it's split between field instruments and DCS developed specifications for the respective items. Mechanical team finalize, as I mentioned, their basis for mechanical design of equipment, which also include static design, thickness calculations, and other parameter estimation. Piping team, they try to finalize main pipe rack design, what could the structure, width, and length of main pipelines, and most of the time piping team, they agree with the client end users that what is the minimum size, probably 4 inch or 6 inch, up to 6 inch. They will be working on design aspects of these piping routings and connections. Yes, then the next step, which starts probably after a few weeks of start of feed, is cost estimation for capital expenditure. This is again a very important stage, and yes, I'm sure most of the end user clients, they have estimated some cost estimates for this plant at the initial days stages. But now when feed has started moving, these cost estimates are or we can say the cost estimate starts moving to from approximation, they start moving to accuracy bit by bit. So most of these cost estimations, they are in initial days, they are based on preliminary communication with vendors. But in the field stages, now when the data sheets are available, vendors are involved, they're expected to give figures or estimates of costs which are more firm than what they might have quoted in initial days. Then the respective disciplines, they start their overall material takeoff. Like for example, civil, they start estimating takeoff for concrete quantity of concrete required. Piping team, they start estimating number of walls and fittings and flanges, etc. are required. Uh, Yes, feed stage studies do involve various studies, including HAZOP. They are also planned and carried out in feed stage. Feed stage usually comes to an end with the submission of deliverables and documents from contractor to clients. Yes, there is a review which is carried out by client, by end users, or if the client is not in a position to have their own in-house team, they usually employs project management consultants, which are responsible for review and technical correctness or assurance of technical correctness of this drawing. So either PMC or client own team, they review these documents at various stages. Now, this is the point wherein there are various submission methodologies followed by companies. Like in Aramco, they call it as stage-wise submission 30, 60, 90, and they expect every document which is listed in or expected to be submitted at that stage will be submitted along with all the documents at the same time. Wherein some other parts of the world, like probably if you're talking about Oman or times in sometimes in UAE, the client expects whatever the document they are ready. The client expect to be reviewed by client or PMC as and when they are ready. And these are just stages of I would say document submissions. Then at this stage of time, client starts getting a feel of overall facility, overall estimation, or overall investment required for this facility. So client also starts preparing for detail engineering stage. Now, in detail engineering stage, as I said, or we will see in the next few slides, detail engineering stage involves a repetition of few activities which are done in feed, but yes, they are also important. And again, the detail engineering stage is more intense compared to feed stage. So at the time when client starts inviting bids for this project for detail engineering phase, feed is expected to be at least 90% completed. And because the data engineering contractors, remember, we are talking about millions or probably billions of dollars of investment. So the bidding or for these projects, if it involves supply, construction, those are very tricky estimates and need to be done very carefully. So most of the time, client don't wait for feed stage to end. They start pushing, sharing documents with engineering contractors in expectation to get bids or cost estimates from them for the facility. Most of the companies who are only engineering companies or engineering consultants, they join hands with the construction companies. There are two types of companies, like I would say which are only engineering companies, and other type is only construction companies. They do join hands and bid jointly for these projects. Then there are other types of companies who have both capabilities, engineering as well as construction capabilities. So they bid on their own. These companies, when I say construction capabilities, we are talking about construction capabilities in the remote part of the world, be it a desert of Algeria or icy terrain of Kazakhstan or Siberia. These construction capabilities, they are very much important, and client need to have uh, a good amount of rapport or good level of confidence on these capabilities of the construction company. So they really play a very important role in these detail engineering stage. Uh, Now we are talking about detail engineering stage on this slide, and detail engineering stage usually lasts again on the size of the project. It lasts for 18 to 22 months. So this detail engineering stage nowadays usually starts with the feed verification stage. This feed verification stage lasts for 4 to 6 days, and it involves detailed review of basis of design from feed stage. Most of the time, this feed verification is involved or is focused on process engineering aspect. But yes, at the same time, other disciplines are also expected to review documents generated by feed contractor and to find out or to try to find out if there are any loopholes in the feed stage. For example, feed contractors, they are most of the time they are forced to end the feed stage as early as possible by the end users. So they tend to keep some open points. They tend to keep some loopholes in the documentation. For example, I can example which I can give you is we are expected to have a certain amount of nitrogen generated as a utility at the site, and the type of nitrogen generation, whether it is from membrane or by other ways, is ideally should be finalized during the feed stage. But utility by far, in most of the cases, is neglected. So these aspects are kept open and pushed to detail engineering stage, wherein any change in these aspects might impact the overall cost considered by the engineering contractors or construction companies. So in feed verification stage, it is expected from the detail engineering consultant or detail engineering company to find out open points like this one, as I mentioned. If we are talking about processes, imagine that from this facility, what you are talking about, the gas is expected to be compressed and sent to a national grid at certain location. So during field stage, there was no information available on what pressure required at the farthest location. This particular point is called as time point, and it happens that no concrete information was available or the basis for this was not finalized. Now this in a way this affects the selection of compressor in the facility because there is no surety on what pressure is required at the outlet of the compressor. So these kind of open points, data engineering contractors are expected to find out during this field stage. They are find out, they are raised, and they are discussed with recorded. They are discussed with the client, and once this field verification stage is usually expected to finish in 4 to 6 weeks, and with the outcome of this should be a field verification report. Uh, as the progress is as the project moves towards the end of field verification stage, multiple fronts for teams are made available. For example, compressor data sheets for rotary, static equipment data sheets for mechanical PNIDs, of initial review of PNID, initial issue of PNID is shared with all disciplines, control data sheets for instrumentation team, and likewise other discipline interaction, which includes mechanical to electrical and piping to civil for structurals and pipe racks. Yes, those are also started in this phase. Now coming back to process discipline, PNIDs, as I said, in detail engineering stage, PNIDs are issued at various stages of the project. These safety studies includes HAZOP and SIL are conducted here. purchase orders for long lead items are issued. Long lead items, when I say long lead items here, includes compressors, turbines, and other high pressure equipments, most probably bullets or similar items. Then in terms of control valves, there are a few high pressure, high duty control valves, which are going to take long lead item for of higher sizes. So these items are identified. Purchase orders are being prepared or developed in these for these items, and they because as I said, the expected duration for this is 18 to 22 months, but for some of the items, the supply period lasts for 20 months, including turbines and all the turbine vendors. They are most of the time they are, or the compressor vendors, most of the time they are loaded with orders. So this involves around 20 months of time, 18 to 20 months of time for them to delivery. Uh, yes, during this phase, a close coordination between all disciplines is very much needed. So PNIDs, as I mentioned in the first point, stages of PNIDs, which are usually and most of the time are issued for approval. This is the first stage of a PNID issue. Then another stage is issued for HAZOP. Then HAZOP is conducted. HAZOP closure report is carried out in this phase. Uh, this is similar to what the feed contractor has done in feed stage. Most of the time, yes, feed contractor they do a feed stage HAZOP. In addition to that, detail engineering stage HAZOP is carried out. After that, issued for design is the stage of PNID, and the last is issued for construction. Now, in the stage of issued for design and issued for construction, this stage usually comes after 12 months or 14 months of the project which has started, and it is expected that the vendor data, including for control walls, safety walls, or all other border items like pumps, then compressors, turbines, other utility packages, cooling tower if it is involves the nitrogen utility generation plant and instrument air. So this data is expected to be available by this stage, probably from the year or 12 months from the start of the project. And this data needs to be incorporated in issued for design and issued for construction PNIDs. So as I said, these are actually the stages, but the same stages are followed in terms of payment milestone, which is expected from client against the issue of these documents. So most of the time, issued for construction PNIDs are issued, but they are not ready, or they are not as ready as expected or as they should have been. So this results in multiple uh, issued for construction stage, like issued for construction 1, 2, or probably I've seen 3 or 4 issued for construction stages of the PNIDs. Uh, yes, as I said, vendor data starts coming in around issued for design stage PNIDs. This data is transferred to respective disciplines via relevant document, like, for example, again, PNID and other interdisciplinary deliverables. Detail engineering for various disciplines ends at various timeframes. Like, for example, if you're talking about process, it ends probably 14 or 16 months by end of issue for construction drawings. Wherein piping, detail engineering for piping, it ends much later stage when they start issued for construction layout and drawings and 3D extracted from 3D model reviews and things like that. Civil, it also ends at a very late stage. Civil is a department which I must say is responsible for major construction related drawings. And the irony is that they receive the data at very late stage from mechanical and piping disciplines, because they are expected to receive data from vendor. Civil receives these confirmed data at very late stage, and they are, unfortunately, they are expected to give documents which are required a very on a very, or at the very first day at site. So this is kind of bottleneck for civil engineers, I would say. uh, now we enter into construction phase, which is again expected to last for 10 to 12 months. Now remember, when I say these phases, these although the duration I mentioned, but these durations are overlapped, and overall estimated time frame for a project from start of the detail engineering is probably 24 to 36 months with a major overlap of detail engineering and construction phase each other. So construction phase starts with basic mobilization to the site and foundation of major items like columns and other turbines and other heavy items like pumps, etc. Then campsite for accommodation of staff, which is also done at a very early stage. Erection of major equipment and pipe rack, yes. Then comes the stage wherein the mechanical completion is done. This mechanical completion, when I say mechanical completion, it involves piping connections, equipment connections, and all electrical instrumentation connections. So this is a major stage from the construction point of view, where mechanical completion is declared and a major payment milestone for the stakeholders. Then comes the pre-commissioning phase, wherein a pre-commissioning is a team which is separately handled either it's a joint team which involves people from client side, people from data engineering, construction, data engineering consultant side, and construction side. They do this pre-commissioning, which is pre-commissioning is if I have to put it in a nutshell, pre-commissioning is getting the plant ready for commissioning, and the commissioning phase wherein you actually start the plant, you actually start taking in the feed, you actually start production, and you actually start producing something which might be off spec, and then you have to reroute it again through the plant and things like that. So these are very critical stages, pre-commissioning and commissioning, and these are very intense stages compared to construction phase. And these involves a lot of brainstorming sessions during commissioning, pre-commissioning, and commissioning stages. And the last stage is guarantee run and handover. So at this stage, the plant is handed over to the operating company. They sometimes this involves another 6 months extension from the commissioning teams to give training to the staff available, or if the staff is new. These are different types of contracts which are entered between the commissioning team and the end user. And that's it from my side.